You can see that in very different places in the world now. That's sadly very common, and I really think that we can do something. You probably know the quote from Gandhi, "Be the change you want to be in the world." So that's just what I do. I really wanted to do something for that, and that's what I do. So I started this company to recycle polystyrene. First of all, what is polystyrene? So polystyrene is all the items that you can see there, and there is different kind of polystyrene. There is the expanded one, the extruded one, and the rigid polystyrene. Our technology is able to recycle all those products in a closed loop. Why is polystyrene not that much recycled today? The first issue is the transportation cost, because EPS is full of air. The second main issue is the contamination, because polystyrene is very often mixed with some other plastic, and there is paper, cardbox, there is rest of food, there is many different things that you need to remove. That's doable to remove it manually. However, it is very labor intensive. And the third point is that polystyrene, expanded polystyrene, the recycled product, is not all the time re-expandable. So that's already good to do that, but you do not really close the loop. So that's a lot of limitation, and at Polystyrene we have developed a technology to overcome those obstacles. How does it work? It works by dissolution. So as you can see there, we put the polystyrene in contact with an essential oil. And that's a very, very safe product. So the hand you see on the video are my hand, because that's really, no matter if you have it on your hand or if you smell it, that's a very, very safe product. And the time of dissolution, that's the real time. This is not accelerated. And in order to prove it to you, I'll do it again. So we have the solvent there. This solvent is called cymene, C-Y-M-E-N-E. And as I told you, that's an essential oil. That's EPS, as you know. So we put it in contact. And it dissolves. It's already done, as you can see. So that's very, very quick, because when you are in waste management, you don't want to wait. This has to be very, very quick, and that's what we do. What's nice also with our solvent is that it is selective of polystyrene. So nothing else than polystyrene will dissolve in. For example, if you have PP or PE or cardbox or paper, it will just happen nothing. Only polystyrene will dissolve, and the balance will just remain there. Thanks to that, that's very easy to remove the contamination just by a basic screening. So our very first step is the dissolution. Then we do a basic screening to remove the other plastic, the contaminant. And that's very quick, and it's okay. It is very labor efficient. After that, you can apply a purification process. That's an option. Maybe you don't need it. If your EPS is white, you don't need to remove any color. However, we also face colored EPS, like Neoport that is gray, or in the yogurt pot, it's often painted in blue and brown for chocolate. So we are able to remove this color thanks to our purification process. That's something very important. And after that, your polystyrene is relatively clean. You remove all the contaminant in suspension, but it remains the contaminant in solution. Like, for example, the infamous HBCD, the fire retardant. And there is also the mineral oil. There is also some other colorant. These products are soluble in cymene, so they will remain in solution. In order to remove it, that's very basic. We add an anti-solvent in this mixture, and the polystyrene precipitates, meaning that it becomes solid and it falls down. So you will have a kind of chewing gum, paste of polystyrene in an overflow made of solvent and anti-solvent. We just flush the overflow. We keep the paste of polystyrene and we send it in a devolatilization system. It could be an extruder or 4-strand pelletizer, it exists different kind of DeWall system. And at the end, we have these wonderful pellets that are completely crystal clear, no color, and what is great is that all what I told you is low temperature. So we never alter the molar chain of polystyrene. We keep all the mechanical properties of the polystyrene. So as you can see, the end product is really wonderful. It is very high quality. It has all the mechanical properties of virgin polystyrene. It is perfectly transparent. So you can reuse it to redo the exact same application. That's how you really close the loop. Then I spoke about the HBCD. When we do the precipitation, the HBCD goes in the solvent. It does not remain in the polystyrene. So that's very, very easy to remove it. And the solvent, I told you we flush the overflow. So this overflow, we send it in a distillation column, and we recover the different solvent in order to reuse it for the next time. So that's a real closed loop. We do not lose anything. Here you have a few pictures of our feedstock. So as you can see, it could be very dirty, it could be post-consumer, or it could be very colored. This is chips of rigid polystyrene. And after our process, we have a very high quality product, completely transparent for GPPS, or very, very wide for HIPS. This technology has a lot of competitive advantages. First of all, I think the capacity to be able to treat any kind of contamination is really a game changer. Because this gives us access to the whole stream. We will accept any kind of polystyrene. And since we're able to remove anything, we can get a very, very high quality product. Second, we are very energy efficient because we don't warm the polystyrene. We are very low temperature. Because we are low temperature, we also have a very high yield because we never alter the polystyrene. So we claim that we can recover 98% of the polystyrene. That's a very, very high yield, and we are very proud of that. As I told you, since we are low temperature, we have a very high quality product because we do not alter the molar chain. And last but not least, we are the shortest loop. I mean that we do not depolymerize the polystyrene. We are plastic-to-plastic technology. So you don't need to repolymerize it because you already have polystyrene. So that's the shortest loop. We are the shortest loop because we are plastic-to-plastic technology, as I told you, but it exists some other technology that are also very efficient, like, for example, depolymerization and degasification. So as you can see, this technology makes a longer loop. However, these are also very good technologies because thanks to that, you can go back to the monomer or to the gas and also install a circular economy that way. However, since that's a longer loop, this requires more energy. But what is positive in depolymerization and degasification is that you can redo some other product. You don't have to do polystyrene. You can do ABS, SAN. With degasification, you can go back to ethylene. So that's very efficient. And I think that we have to work together because, you know, there is not one magic solution that would fix all the plastic issues. So definitively, there is enough room for everybody. And if we work together, each of us will find their specific segment in order to collectively fix the plastic issue. Now a few pictures. This is a design of our Montreal plant. So this plant is in Montreal, Canada, and it is up and running since summer 2018, so that's 1 year and a half. This plant works at 125 kilograms per hour, and that's a continuous process. That's very efficient. We are very proud of that. The polystyrene that is recycled in this plant is sold to Owens Corning. Owens Corning is a great insulation company. They also partner with Dow, and they are very happy with our product. So I really hope that I convinced you that polystyrene is actually recyclable and recycled, and I hope you will join us for a greener tomorrow.